Hi, this is Adil. I am from Vailtech High-Tech Dr. Rangarajan Dr. Sagundola Engineering College. I am from the Department of Chemical Engineering and the title of my project is Analysis of Process Water Quality Requirements for a Nuclear Power Plant. My guides are Dr. Rajamani and Mr. Vinod Kumar and my external guide is Mr. Silas Popuraju, who is a control engineer in the Kodangulam Power Plant. My project mate is Mr. K. Veeramani. Introduction. Kodangulam Nuclear Power Plant is the single largest nuclear power station in India situated in Kodangulam in the Tirunelveli district of the southern Indian state of Tamil Nadu. Kodangulam Nuclear Power Project is scheduled to have 6 VVR reactors built in collaboration with Atomstroy-Export, a Russian state company, and Nuclear Power Corporation of India Limited. Aim and the objective. The main aim and the objective of the project is to evaluate the parameters involved in the ion exchange process, which is being carried out in the demineralization section of the nuclear power plant. The parameters of both sea and demineralized water was calculated and their properties were then compared. Now, to talk about the parameters which are involved in the project, the parameters which are involved in the project are the pH. Second one is the total dissolved solids, which is also set by TDS. Third one is the chlorine content, which is the amount of chlorine. And fourth one is the salinity, which is the amount of salt content. Action plan. The values of various parameters like TDS, pH, chlorine content, salinity of water was first found out. The parameters was found out for demineralized water as well. The various standards were found out from Perry's handbook and calculations were based on the data obtained from them and from reliable sources in the internet. Literature review. These are the literatures which we have reviewed, which has helped us to do the project in a very good way. The main literature which we have reviewed is the first literature, which is the process evaluation of ICD for water recovery enhancement in production scale brackish water desalting. And the given below literatures also helped us in somewhat a way. Formula and calculations. The calculations were done by using the below formulae. That is, the TDS is found out by conductivity into factor and the salinity is found out by conductivity by 1000 whole power 1.09 into 0.4 and chlorine content is found out by salinity into factor. Procedure. Demineralization of water. Any process used to remove minerals from water. However, commonly the term is restricted to ion exchange process. Process utilizing special manufactured ion exchange resins which remove ionized salts from water. They can theoretically remove 100% of salts. This is done by accidental trapping of the resin. General initial water ion exchange purification system is designed for the following purposes. Receive partial DM water from desalination plant and storing it in storage tanks. Ion exchange purification of partial DM water to DM water and storing. Supply DM water to condensate and feed water makeup, reactor and turbine auxiliary makeup, and service supporting systems for making up of auxiliary boiler. Purpose. The main purpose of the DM plant is to remove dissolved mineral salts from supplied water. The DM plant design capacity is 180 m3 per hour. It has 4 streams and normally 2 streams will be in service and 1 will be in standby. The DM plant gets source of water from desalination plant and it will be supplied to partial DM water. The partial DM water passes through second stage ion filter. Cation exchange process. Cation exchange filter uses the resin in hydrogen form. This resin is also called as the ambelite. The relevant chemical reactions are NaCl plus HR gives NaR plus HCl. Similarly, MgSO4 plus 2HR gives MgR2 plus H2SO4. And next to see about the anion exchange process. The anion exchange filter uses the resin in the hydroxide form, whereas the cation uses the hydrogen form. The relevant chemical reactions are HCl plus ROH gives RCl plus H2O. And similarly, H2SO4 plus 2ROH gives R2SO4. Mixed bed process. The mixed bed uses the resin cation in hydrogen form and anion in the hydroxide form. The conditions to be fulfilled by the water coming out of the mixed bed are pH must be 6 to 7, specific conductivity must be less than 1 microsecond per centimeter and chlorine content should be less than 0.005 ppm, which is a parts per million. Regeneration. For cation bed, the resin is regenerated with 3 to 4% H2SO4 solution. 2 NaR plus H2SO4 gives Na2SO4 plus 2HR. For anion bed, the resin is regenerated with 3.5 to 4.5 Na solution. RCl plus NaOH gives NaCl plus ROH. For mixed bed, both of them are combined to obtain. Calculations. For demineralized water, total dissolved solvents. The total dissolved solids is found out by conductivity into factor. Here the conductivity is 0.01 multiplied by the factor which is 0.67. And so the total dissolved solids is 0.0067 ppm, which is the parts per million. And next, the calculations for salinity is done. Salinity is found out in PPT, which is parts per thousand, and it is given by conductivity by 1000 the whole power 1.09 into 0.4. That is 0.01 divided by 1000 the whole power 1.09 into 0.4. That is 1.4 into 10 power minus 6 PPT, which is parts per thousands. And the calculations for chlorine content. The calculations for the chlorine content is given below. Chlorine content is equal to salinity into factor. That is, the saline value is 0.4 into 10 power minus 6 into the factor is 569. It is 1.9 into 10 power minus 4 ppm parts per million. The pH is found out by using the data obtained from the internet. That is, the pH is 6.5. Now, for the calculations of seawater, TDS is found out by conductivity by 1000 the whole power 1.09 into 0.4. That is 550 into 0.67, which is obtained as 368.5 ppm, which is parts per million. And now, to find out the salinity value of the seawater, the salinity is found out by conductivity by 1000 the whole power 1.09 into 0.4. That is 550 by 1000 the whole power 1.09 into 0.4. That is 2.08 into 10 power minus 1 ppt, which is parts per thousands. And now, to find out the chlorine content and pH, the chlorine content is found out by salinity into factor, which is 550 by 1000 the whole power 1.09 into 0.4. That is 2.08 into 10 power minus 1 ppt, which is parts per thousands. And the pH is obtained from the internet, and it is also calculated as 8.2. Comparisons of the various properties are given below. TDS, salinity and chlorine content were compared for demineralized and seawater. As seen from the above values, it has been observed that the parameters of the seawater are found to be higher than that of the demineralized water, and this is an important point in the project. Now, to say about the reference, these are the books we have referred for doing our project. The Perry's Chemical Engineer's Handbook, the product specification from Neochem PLC, material safety data sheet, health risks from drinking demineralized water, product data sheet of Clear Make Path. These are some of the references which we have used. And the continuation is liquid discharge for inland desalination, which is done by AWWA Research Foundation, and developments in high recovery brackish water desalination plants and increasing conversion in membrane filtration systems.